Right. Today we are going to talk about cavernous sinus in detail. Right. Cavernous sinus is one of the dural venous sinuses. So before really I go into detail of cavernous sinus, I would like to mention that what is the basic concept of dural venous sinuses. What are dural venous sinuses? I will make you a very simple diagram that let's suppose it's a very simple diagram. Let's suppose this is your cranial cavity. Okay, here are your ears. I cannot make a simpler diagram, right? Now, actually Cranial cavity inside is lined with Dura Mater. What is the meaning of Dura Mater, Dr. Sahab? ये Dura cell वालों ने तो नाम नहीं रख दिया जी.
Stronger. This is a type of meninges. Dura Mater, applied matter. Dura Mater is the tougher one. Toughest one.
Right. He's right. Dura mean hard, tough. Matter mean mother. Actually, it's a tough mother which protects the central nervous system. So he's very right. So now what we can see, Dura Mater basically has two layers. One layer which is very faithful. Faithful to what? Faithful to the bony, internal bony lining. So the faithful layer of Dura Mater, I can draw it with, okay, green color, right? Or which, okay, red color. Now this red color of Dura Mater, this is red layer, this is very sticky with the bone. It is very sticky with the bone, and wherever bone goes, it goes with it, right? This is very faithful kind of layer of Dura Mater, right? So it is covering interior of the cranial cavity, right? Now, but it has one more layer with it, right? That is, second layer is also Dura Mater, but that is less faithful. At some places it departs from the. Now the second layer, which is also there, first I will make it very simple. This green layer, this is also the layer of Dura Mater, and this layer is called, yes, which layer? Meningeal layer, right? This layer is meningeal layer, the green one is meningeal layer, and this one which is sticking with the bone, this is called periosteal layer. But such periosteum which is lining inside of the bone, that part of periosteum is called endosteum. So we can say it is also endosteal layer. So this layer is which layer? Endosteal layer, right? Actually it is periosteum, but that periosteum which is lining the skull from inside, that is called endosteum. So now what we have learned, that Dura Mater is one of the meninges, right? And Dura Mater has two layers. One is endosteal layer, which is very faithful with the bone. It is a sticky layer. It is a sticky layer, like a very faithful wife, right? And other layer is like a girlfriend, you know. What is that? Less faithful, right? Even though try to get along with, but this layer, this is called meningeal layer, right? Now, why I say it is less faithful? Because at some points it may separate, right? Detach from the endosteal layer, right? And make some sort of infolding, right? For example, it moves like this and like that. This is just an example. Or at some other place, it moves away from here and become like this. In this way, when this meningeal layer of Dura Mater, less faithful layer of the Dura Mater, more this layer, when it detaches, right, away from the endosteal layer, a gap is produced, right? And this gap, right, this gap is usually filled by the venous blood, right? There's a purpose in this unfaithfulness also, that here actually venous blood, right? Venous blood is entering into this space created in between the two layers of Dura Mater, and this venous blood is coming from where? Mostly it is coming from cerebral hemisphere, right? This venous blood is coming. It is coming also from the bones around this area. It is also coming like ophthalmic veins or emissary veins communications. But basically this is, so what we can say now, this space which is created by separation of two layers of Dura Mater and full of what? Venous blood, right? This space is called dural venous sinuses. What is it called? Dural venous sinuses. So, what are dural venous sinuses? Dural venous sinuses are very specialized venous channels, right? Present intracranially, right? Created by separation of endosteal and meningeal layer of Dura Mater and filled with the venous blood and lined by endothelium. Wherever in our body blood is there, if you don't want blood to clot, it has to be endothelial lining. So what we can say, now I'm going to enlarge it, that let's suppose this is our, which layer is now? I'm going to enlarge only this area. Endosteal, and let's suppose what was this layer going? Yes please, meningeal, and here it was little bit departing, and space created in between them is full of venous blood, and this is called dural venous sinus. The important point which you need to remember, that this layer, this whole channel or space is lined by endothelium, right? Endothelial cells, you know, they are very important. They help the blood not to clot, right? Not to clot. So basically, now we can add one more feature, that dural venous sinuses are endothelium lined special spaces created between the two layers of Dura Mater. And one more area. Now if this is venous channel, most of the venous channel in our body have valves. Most of the venous channels in our body have valves, right? But dural venous sinuses, rather the question should be, which dural venous sinuses have valves? No dural sinus has valves. Very good. No, this is true. These are not having any valve. So it means that it is possible that in dural venous sinuses, if around them or inside them local pressure changes, blood can flow in either direction, right? So these are valveless. They don't have any valve. Am I clear up to this? So this is what is the basic concept of dural venous sinus, right? Now, central nervous system has many dural venous sinuses, but today we will specifically focus on cavernous sinus, right? So let's go and talk about the cavernous sinus. First of all, I would love to mention that in central nervous system or in the cranial cavity, exactly where the cavernous sinus is located, right? First we learn where exact point, where it is located. So let's suppose from my, do you like my haircut? Yes. It's a new haircut, I tell you, brand new, okay. So why I remember it? Because I want to give you a concept that if you remove the cranial vault and remove the brain also out of that and then look inside, right, you will look at the base of the skull, is that right? From inside. And how it will look if you have removed most of the things from inside, right? It will look something like this. Okay, so, oh my God, it's not balanced, but anyway, no problem. World is also not balanced. I'm making just these structures so that you know that ears are on the side and nose is in the front, and here are few. Now, when you draw the cranial cavity base, this is a central structure here. What is it? Sella turcica, very good. And from here, greater wing of sphenoid or lesser wing of sphenoid? Lesser wing of sphenoid. Lesser wing of sphenoid, right? And here it is what? Petrous part of, oh my God. Why you are after the greater wing of sphenoid? That is not here. That is somewhere here, right? We'll talk about that later. Okay. So what is this? Petrous part of temporal bone, right? Now, if you can identify these landmarks, right? Now you must be knowing these are anterior cranial fossae, these are middle cranial fossae, these are posterior cranial fossae, and of course you know the big thing here. Yes. What passes through it?
Foramen magnum, spinal cord passes through it.
Spinal cord or brainstem? What really passes? It's the end of the brainstem and beginning of the spinal cord, but don't tell anyone esophagus passes from here, right? Okay. So this is basic. Now this is the base of the cranial cavity. Somewhere here, cavernous sinus is located, right? Exactly where? Actually, cavernous sinus is located on the sides of what? Sella turcica, right? Of course, sella turcica is the top of the body of sphenoid bone. So there is one cavernous sinus here, right? There's one cavernous sinus here looking to you, and other cavernous sinuses here looking to you. So where are the cavernous sinuses? We can say they are situated in middle cranial fossa, just on the lateral side of the which sella turcica, not sella turcica, more truly speaking, on the lateral side of body of sphenoid and pituitary gland. Is that right? Now, this is the location, right? Now, from where it extends anteroposteriorly, let me make it rotated, and I'm going to now draw my cavernous sinuses with this view, right? And if I make that, it should become something like this. You know, I have a big brain, but I never intended to make a big nose anyway. So here it is. Yes. Now you understand what are the structures I've made. There's no fun in telling you it is crista gali and here is cribriform plate of ethmoid bone, and of course you know that here is your eyeball. Am I right? You have many balls and these are eyeballs. And then, okay, let me make it a little more bigger for you. So this is body of sphenoid, right? Now, cavernous sinus, one should be on right side and other should be on the left side. So there are two cavernous sinuses which are paired structure in the middle cranial fossa. Now, interiorly, this is the orbital cavity, this one, and of course there is the other orbital cavity on that side, right? And here there is a structure which, what is this? Very good. I'm impressed by some of you. You know fissures also. Superior orbital fissure, right? Now, superior orbital fissure is here on both sides. Cavernous sinus basically extend, okay, before I go into detail, what was this bone? Petrous part of temporal bone, and here also this is petrous part of temporal bone, right? Now, cavernous sinus extend from, now I'm going to draw it here. This is the top of the cavernous sinus. Right? Now, cavernous, of course, there's on other side also. There's no fun in telling you. You know it already by now. Now, cavernous sinus, interiorly, it approaches which structure? Superior orbital fissure, right? And posteriorly, it extends up to the tip of the petrous part of temporal bone, right? So we can say cavernous sinus are paired structures which are dural venous sinuses created by a separation of two layers of Dura Mater. They are situated on the sides of sphenoid, body of sphenoid and pituitary gland, right? They interiorly they extend up to the superior orbital fissure, and posteriorly they reach up to the tip of the petrous part of temporal bone. It's almost 2 centimeters long and 1 centimeter wide. Is that right? It's 2 centimeters long and 1 centimeter wide. Now, this is the basic structure. Now I will make a diagram from the side, right? And we'll go into detail of it. Any question up to now? It was just a basic concept. What is cavernous sinus? Why we call it cavernous sinus? Any question? Why we call it cavernous sinus? No one want to answer me.
Yes, it is divided into caverns.
What is caverns?
Caverns are the small
Spaces. Actually, cavernous sinus, he is very right. Cavernous sinus is having lot of, you can say, spaces or caverns, right? It looks like if you cut the cavernous sinus, right, it will show trabecular structure, right? And because it has multiple channels within it, right, within the cavernous sinus, there are multiple what? Caverns. But what are exactly those caverns? Let me tell you, before you tell me something new. Cavernous sinus is called cavernous sinus because its cavity is full of very thin walled endothelium lined tubes and spaces, right? So it is not one space, it is just like a one box having many tubes inside it and many spaces inside. So we can say cavernous sinus anteriorly or internally has a meshwork of venous channels endothelium lined, right? Because the multiple channels, they are intercommunicating, and when we cut them, they look like trabecular structures. So we call them, they are like lot of caverns inside it. Caverns means small caves, small spaces. We call it cavernous sinus. Is that right? So anyway, now cavernous sinus, we know the basic exactly where it is present. Let me tell you how it is created. A little more detail, right? That how exactly it is created. It means already you know that to create a cavernous sinus, two layers of Dura Mater should become unfaithful and depart from each other. Now let me draw the body of sphenoid bone, right? And here there is greater wing on the side. Here is the petrous part of temporal bone going on the side, and then you know that you have ears on the side. Is that right? I don't know, maybe okay, put something here so that females can be happy. Okay, now here we have to see how the cavernous sinus is exactly produced, right? There was sticky layer, endosteal layer, faithful layer. It's moving towards this side, right? It remains faithful with these bony structures. Even if there's a foramen here, what is the foramen exactly under the cavernous sinus? Which is the foramen just under the cavernous sinus? Foramen lacerum. Very good. Why we call it lacerum? Because it is lacerated, it's irregular, excellent. So anyway, there is foramen lacerum here, but I'm talking about endosteal layer, right? Endosteal layer faithfully goes from petrous part of temporal bone, medially, runs over the body, then from here moves, and in this way it goes to the other side also, right? Now what is this layer? Endosteal, right? With it, other is moving. What is this? Yes, please?
The meningeal layer.
Meningeal layer. Now, as meningeal layer is approaching, initially they are together. As it approach, what is this? Sphenoid bone, right? Before it, here it becomes unfaithful, right? And it departs from there and it goes superiorly, right? It goes upward. And when it is going upward, it really goes upward, and then it moves medially, right? But it doesn't stop here, not at the top. It moves more than expectation medially, and then it comes back and moves here, right? And again, now, again it becomes faithful for a while. Is that right? But you know, it's a little naughty. Okay, so again it will depart and make a beautiful fold here, and then it will go, and eventually it will come down, and then it becomes faithful and sticky with that layer. So now you can see cavernous sinuses are created like this. You understand exactly how they are created? Right? That basically endosteal layer remain with the sphenoid bone and with the base of the, what is this? Middle canal fossa. But as meningeal layer approaches, right, it detaches from the endosteal layer, right, and it moves superiorly, then medially, right, and eventually making a special fold here and then coming down, and again they become together at this space, which is the top of the body of the sphenoid. The top is called sella turcica, right? Why we call it sella turcica? Why we call it sella turcica? Turkish saddle. Turkish saddle. Who is riding on this saddle? Pituitary gland, the chairman of Endocrine Society. Is that right? So pituitary gland is here. This is stalk of pituitary gland, and here it is pituitary gland over here. Is that right? Now, this part of meningeal fold, which is making overhanging over the pituitary gland, this is called diaphragma sella. What is this called? This component is called diaphragma sella, right? And it has a central aperture through which the pituitary stalk goes upward, and of course it gets connected under what? Very good, hypothalamus, excellent. Now, this is how it is made. Now let's define the walls. Actually, if we define the walls, now onward in our lecture, we will consider this as a floor of cavernous sinus. What is it? Floor of cavernous sinus, which is made of endosteal layer. Part of a medial wall is also made by endosteal layer, right? And lateral wall is made by, yes, meningeal layer. Roof is made by meningeal layer, very good. And upper part of medial wall is also made by meningeal layer. Now you exactly know how it is made, dural sinus, right? So in the same way it is here, right? That roof is made by meningeal, lateral wall by the meningeal, floor by endosteal, and part of the lower part of the medial wall by endosteal, and upper part of the medial wall made by meningeal. Done? Clear? Okay. Now we know where cavernous sinuses are situated, what is their size and dimension, and how exactly they are made. Now we see what are the structures, important structures related with cavernous sinus.